Lesson 8.4, Solve Problems Using Angle Relationships. In this lesson, we're going to expand on our ideas and knowledge of using angle relationships such as adjacent angles, vertical angles, complementary angles, and supplementary angles to solve problems. Example 1. Solve problems involving adjacent and vertical angles. You can see in the picture diagram that you have lines AD and line CE intersecting each other at point B. In this case, you're looking at roads that do not intersect at a 90-degree angle, and they are asking us to find the measure of angle ABC, which for this problem would be this angle right here, and to find the measure of angle DBE, which is this angle down here. Okay, and what you might notice is those angles are exactly across from each other. So let's look down here at the example and how they work it out. So we're going to look at vocabulary first. Examine how the angles are related. Angles that are opposite each other are called vertical angles. So vertical angles have equal measures. So angle ABC, right here, is equal to angle DBE, right here. Okay, they are across from each other. Non-overlapping angles that share a ray are called adjacent angles. So if they share a ray and they are next to each other, so next door neighbors, for example, they would be adjacent angles. So angle ABE, this angle right here, is adjacent to angle DBE right here because they share ray BE. That's this ray right here. Okay, that connects them. And we can use this information to write and solve an equation to find the value of x. So M stands for the measure of an angle. So we say the measure of angle ABC is equal to the measure of angle DBE. So go back up to the diagram. And in that picture, you see that the angle measure of ABC is x plus 35 degrees. That's this piece right here in your problem. And the measure of angle DBE is 2x plus 10 degrees. And because those two angles are vertical angles, the measures are equivalent. So we're going to solve this equation for x by moving the variable terms to one side and the number terms to the other. So let's take a look at what they did, and then we're going to do the same thing over here on the side, and we're going to make the same sort of equation solving process that we always do. So here's my equation with the two angles equal to each other. So let's first decide to move the number. So let's add 10 to both sides. On the left side we get x plus 45, and on the right side we get 2x, because subtracting and adding 10 makes 0. Now I'm going to move the variable term. So let's take away the x from each side, and we get 45 on the left, and 2 x's take away one of those x's, leaves us with the other x, and that must mean that x is 45. Now that's the value of x, but that doesn't tell us about the angle measure. Okay, the angle measure can be found by substituting the 45 in place of x in either of those two equations. So x plus 35 for angle ABC means I need to put 45 in place of x and then add those two numbers together to get 80 degrees. So the measure of angle ABC equals 80 degrees. Since angle ABC and angle DBE are equivalent angles, then that means the measure of angle DBE is also 80 degrees. Now let's complete the try it question. Angle MNQ, that would be this angle right here, and angle PNR right here are vertical angles. What is the value of x? Vertical angles are equal, so the equation, I'm going to make an arrow here because I can't fit it all in there. 3x minus 6 equals 114 degrees. So I've taken these two expressions and I've put them equal to each other. Can be used to find x. Now we need to find the value of x. So let's do that over here. 3x minus 6 equals 114. So this is a two-step equation. I need to first add 6 to both sides. And we get 3x equals 120. Oops. Except I'm having trouble writing. Let me try that again. There we go. Now I need to divide both sides by 3 to get the value of x. So the value of x is 40. What we also know is that the angle labeled MNQ also has to be 114 degrees because those two angles are the same, but the value of x is just 40. The angle itself is 114 degrees. Next, let's try example 2, where we're going to be looking at solving problems involving complementary and supplementary angles. You have got to memorize these two facts. Complementary means that they have a sum of 90 degrees, and supplementary means that they have a sum of 180 degrees. Those two terms you must memorize. Now let's look at A. Ray EG, that's this ray right here, splits right angle DEF into two angles. Angle DEG, that's this piece here, and angle GEF, that's this piece right here. Find the value of x. Well, since angle DEF, that would be this angle here, is a right angle, that means the two parts of the angle must equal 90 degrees. So the first part, the measure of DEG, is 3x, and the measure of GEF is 36. So 3x plus 36 must equal 90. And we solve that just like we did every other angle. So subtract your 36 from both sides, and 3x has to be equal to 54. Then we're going to divide both sides by 3, and x is 18. Now look at part B. The two angles shown are supplementary angles. Supplementary means that they add up to total 180 degrees. So in this case, we have two expressions again, and we're going to put those two expressions together, and they must equal 180 degrees. In order to solve this one, we're going to first combine our like terms. So x divided by 2 minus 4 plus 50 equals 180. First, we're going to combine these two parts because they are like terms. So x divided by 2 plus 46, because subtracting 4 and adding 50 leaves you with 46, equals 180. Now we're going to subtract 46 from both sides to isolate the variable and get x divided by 2 by itself. And in this case, x divided by 2 equals 134. Now, you've got a division equation here, so to solve it, we need to multiply both sides by 2. And x has to be equal to 268. Example 3 can be somewhat overwhelming. Finding the measure of an unknown angle when you have 3 intersecting lines and all sorts of extra information there that's not needed can sometimes be a little bit, intimidating. So when they ask us to find the measure of angle PAR, my first instinct is label that angle. See how it relates to other angles around it. For example, do you see anything that helps you with the relationships? And what I noticed immediately is that there is a right angle marker in the corner here that marks angle KAP. So in this case, angle KAP is equal to 90 degrees. What else do I know? Well, I also know that angle KAP can be split into two angles, angle KAR and angle RAP. Now you might notice that angle RAP is the same as angle, let's change this around here, PAR, which is the one that we're looking for. So angle KAR can be described using the expression 2x plus 16. We don't know what angle PAR is equal to. Okay, that's a question mark. But we know that their total has to be 90. So now the question is there any other relationships that we can use to get that information that we need here? Well, in order to do that, we need to know a little bit more about another relationship. And you can see here that the 2x plus 16 angle KAR is equal to, because it's a vertical angle, with angle GAU or UAG, which is 6x. Because those two are vertical angles, they must be equal. So 2x plus 16 must be equal to 6x. And when I solve that problem looking for the value of x, I end up moving the x term. Okay, so I'm going to subtract 2x from both sides because I want all the x's on one side. And I get 4 x's left on the left side and 16 on the right. Dividing by 4 gives me a value of x equals 4. Now that's helpful because now I can use that value of x to find out what 6 times x is, which is 24. So this angle is 24 degrees. And what that also means is that the 2x plus 16 must also be an angle that's 24 degrees. Okay? And because KAR is 24 degrees, I can say 24 plus what number, in this case the measure of angle PAR, equals 90. Well, if their total is 90, then the measure of angle PAR must be the difference between 90 and 24. In this case, 66 degrees. So by using your angle relationships here, you can definitely solve problems that are more complex and involve more angles. Next, we're going to move on and try some problems in the practice and problem solving.